This is a problem worked through for problem number 4 in lesson 3.2, mass and weight. Now remember that mass and weight are two different quantities. Mass is the amount of stuff, the physical volume within an object, or in this case, within an animal. The weight is the force of gravity affecting that mass. So your weight will always depend on where you are in the universe, on Earth, on the moon, on Mars, or on another planet. In this problem, we are needing to calculate both the mass and the weight of 4 different animals before we take a trip through the universe. Now, one other thing, mass will always have its unit in kilograms. Kilograms is always the unit for mass. So we know before we even do any calculations that this mass right here for this turtle is going to be kilograms. So we can just go ahead and put that in. Now here with force, with weight, the unit for that is always going to be newtons. Now remember, a newton is 1 kilogram meter per second squared. So mass times acceleration. So our formula to calculate weight, the force of gravity, will always equal mass multiplied by the acceleration due to gravity. So this is the formula that we're going to use over and over for these problems. So our crocodile, or maybe that's an alligator, but he has a mass of 100 kilograms, and we need to find his weight. So for this one, the force of gravity equals mass times the acceleration due to gravity, which is 100 kilograms multiplied by 10 meters per second squared. That gives us 1,000 newtons. So his weight on Earth is 1,000 newtons. Now here, the badger has a mass of 58 kilograms. We're going to do the same formula. It's mass times gravity. But instead of a mass of 100 kilograms, we're going to do 58. So 58 kilograms multiplied by an acceleration due to gravity of 10 meters per second is 580 newtons. Now our box turtle, we're told that his weight is 225 newtons, and we need to find his mass. So that means we're going to take our formula. Force of gravity, weight, equals mass times gravity. But we need to solve for mass. So that means we're actually going to divide both sides by gravity, and we'll get mass equals the weight of the turtle divided by the acceleration due to gravity. Or in other words, 225 newtons divided by 10 meters per second squared. Now, remember, Newton divided by meters per second squared, if 1 Newton is a kilogram meter per second squared, when we divide by meters per second squared, we're actually just canceling out this part of the Newton. So we're left with kilograms, which when we do 225 divided by 10, we get 22.5. Newtons divided by meters per second squared leaves us with kilograms, which as we know is the unit we need for mass. So 22.5 kilograms. And then finally, we have our flying squirrel, who apparently needs to go on a diet because an 8.9 kilogram flying squirrel is almost 18 pounds, 17 pounds. That's very heavy. So we're going to multiply this by 10 meters per second squared, same as we did with the alligator and with the badger. A mass, in this case, of 8.9 kilograms multiplied by the acceleration due to gravity of 10 meters per second squared, we get 89 newtons. And that's how you calculate mass and weight for 4 animals on Earth. Now remember, if you were on the moon or another planet with another acceleration due to gravity, your weight would vastly differ, but your mass would always be the same.